My name is Michael Geist. I'm the Vice President of Product Management with SES Space Defense, and today I'd like to spend a little bit of time with you to talk about the value of all orbits. There are two key concepts that I really want to focus on today. The first of those concepts deals with coverage, latency, and congestion. And the second concept relates to availability and scalability. Let's take a look at the three orbits in terms of coverage and latency. Let's start with the low Earth orbit. The low Earth orbit is closest to the Earth and has the lowest inherent latency, but it also has the smallest coverage area. Next, we have the medium Earth orbit, where SES has launched a constellation of M-Power satellites to provide equatorial global connectivity to its customers. That constellation has a larger coverage area and slightly higher latency, but still responsive for native cloud applications. Next, we have the geostationary Earth orbit, where SES also has a constellation of satellites that provide the largest coverage area possible from satellite communications. Let's take a look at the three orbits from a latency perspective in accordance with the Open Systems Interconnect model plus congestion. The low Earth orbit has a physical layer latency of about 50 milliseconds. When you add in congestion of user traffic across that network, that can provide variability in latency of up to 250 milliseconds. The medium Earth orbit has a physical layer latency of about 150 milliseconds. And with the same congestion and application level latency, it can range to about 300 milliseconds. Still within the blink of an eye and roughly the same as low Earth orbit. Geostationary orbit has a physical layer latency of about 650 milliseconds. And with congestion, can go above that towards about a second. Let's take a look at each of these orbits from an application perspective, given those latency and congestion numbers. So low Earth orbit is best for internet traffic based upon the satellite's proximity to Earth and the low latency at the physical layer, even irrespective of the congestion impacts to that orbit. Low Earth orbit is fair for enterprise traffic given the variability of latency with applications and the potential of availability and lack of availability because of congestion in terms of number of users. Low Earth orbit is poor for broadcast connectivity because of the small coverage area and the number of rebroadcasts to extend that broadcast out to the greatest number of users. Medium Earth orbit is fair for internet traffic based upon its slightly higher latency and dedicated traffic. MEO is best for enterprise traffic that requires more consistent latency of users and limited congestion. And likewise, MEO is poor for broadcast because of its limited coverage area in comparison with the geostationary orbit. Of course, that leaves the geostationary orbit. Geostationary orbit is fair for internet traffic. It's poor for enterprise traffic that includes cloud native applications which require better than 650 milliseconds of latency. And it's best for broadcast traffic because of its geographic reach. As you can see, all orbits provide value based upon the different applications that customers may use. And SES is invested in a variety of these orbits in order to provide best-in-class services to our customers. Let's take a look at the value of all orbits from a different perspective now, one of availability and scalability. What I've drawn here is a map of the world with population density shown by latitude and longitude. And I want to take a look at the different orbits and how they play out across this map of the globe with one another. If I start with the geostationary orbit and look at coverage of that orbit, and I add other geostationary satellites into this picture, you can see that we cover quite a large swath of the world. We also leave gaps between geostationary satellites of lack of availability in coverage. The medium Earth orbit does a nice job of filling in the equatorial coverage gaps left by the geostationary orbit. When we add low Earth orbit into the picture, we're going to find a unique perspective offered by the low Earth orbit. And the more lines that I draw representing the low Earth orbit, the clearer the picture becomes. And that picture is the amount of satellites and dwell time over polar regions as compared with the satellites and dwell time over equatorial regions. So you can see when you add each of the orbits together, they fill in the gaps globally, providing the best availability for users with the least amount of congestion. If we look at this a different way, the medium Earth orbit provided by SES's mPOWER provides the best availability and scalability with the least amount of congestion in the equatorial region, which happens to be where the predominance of the population of Earth resides. The low Earth orbit provides the best availability and scalability in the polar regions, where the dwell time is greatest and the least number of satellites are necessary. And geostationary orbit provides its best availability and scalability off of equatorial up to the polar regions. And from this, you can see that the value of using all orbits in network connectivity provides the best value to users. I'd like to conclude this video today by providing a couple of use case examples of the value of all orbits working in conjunction with one another to provide global connectivity to customers. Let's start with a map of Europe and Africa, and we'll add a ship. And that ship may need to traverse the ocean north and south, far above and below the equator. We can also have an aero intelligence, surveillance, and reconnaissance application that can be tasked well above and below the equator. If we add in the medium Earth orbit that we described earlier, and we consider what we described earlier in terms of the LEO orbit, we can see that as the ship traverses through the coverage area of one orbit into the coverage area of another orbit, these mobility platforms leave the optimal coverage region of one orbit and move into the optimal coverage region of another orbit. Taking advantage of all orbits provides the best connectivity, the highest throughput, the lowest latency for the applications in demand. As SES is one of the very few companies focused on all-orbit connectivity, we stand ready to assist you in meeting your application needs, independent of orbit, independent of market, whether we're talking about government or commercial applications.